Welcome to the U.S. Center. Thank you for joining us today. My name is Kate Calvin. I'm NASA's Chief Scientist and Senior Climate Advisor. Today, NASA, along with our partners at the U.S. Environmental Protection Agency, the National Institute of Standards and Technology, and the National Oceanic and Atmospheric Administration will be discussing our efforts to provide open source data to support reductions in greenhouse gas emissions. To kick us off, I'm pleased to introduce NASA Administrator Bill Nelson.
Hey, thanks for being with us today. If you were here earlier, you heard us talk about the 25 spacecraft that we have in orbit, which includes also some instruments that are on the International Space Station that are pointed at Earth, that are giving us data. And that data has become very, very important as we are trying to confront climate change. So, for example, we put up a satellite called SWAT, and it is giving us for the first time, the elevation of fresh water. We've had the elevation of the oceans before, but lakes, rivers, streams, reservoirs, all a part of what we are compiling together in order to have a very precise understanding of what's happening to us Earthlings on planet Earth. And over the course of the next decade, we're going to put up 4 more great observatories that when all of that information, the first of the 4, by the way, is going to be launched by India just in the first quarter of next year, 24. And all of these great observatories with what's already up there is going to give us this very precise understanding. Part of that understanding is the information that we're getting on greenhouse gases. And so we want to make it easy for people to access this information. We have set up at NASA an Earth Information Center, which puts this up real time. But in addition, with other partners in the government, we're setting up a new website called earth.gov, earth.gov, G-O-V. And in it, and what I am going to announce today, is that there will be a site on earth.gov that will be the Greenhouse Gas Center. Easy to access, easy to use, up to the minute data on greenhouse gases. It's going to enable all of you, our scientists, everyday Americans, policy makers, to access curated, easy to understand data sets. It's created by NASA and our agency partners, nonprofits, and the commercial sector. Now, one example, for example, is from NASA's EMET instrument that it's on the ISS. And EMET was first set up to detect sandstorms that put up mineral dust. And that mineral dust in the atmosphere has an effect on our climate. But lo and behold, we found something that we didn't expect. EMET was also detecting methane coming from very specific locations. And some of those are big, but this gets down to 100 feet by 100 feet by 100 feet. You can get it down into that level of a specific location for the emission of methane. Locations that we didn't know anything about before. and it has now identified 750 methane sources since August a year ago, sources of methane emissions that we didn't know anything about. Well, what the Greenhouse Gas Center is going to do is an example of open sharing of scientific data. And it's going to create more data sets, just like I gave you an example from EMIT. Long time ago, 1968, the first mission to the moon. Borman, Lovell, and Anders. And Bill Anders, when he took that photograph that is so iconic of Earthrise, they were coming around the backside of the moon, and all of a sudden, he sees the Earth rising as they're coming over the horizon of the moon. And by the way, just to let you know, they weren't expecting it. And the transmission from the Apollo capsule of the 3 astronauts is, wow, where's the camera? Where's the camera? We got to take this. And finally, Anders gets his hand on the camera and takes that iconic photo that we now know as Earthrise. And this is what he said about that trip to the moon. He said, "We came all this way to explore the moon, and the most important thing that we discovered was the Earth." So we're going to try to continue to discover the Earth, especially with these new tools and with this new tool of the Greenhouse Gas Center. And now I want to introduce you to one of our partners. He looks like an NFL football player, but he is our head of the EPA. Come on up, Dr. Michael Regan.
Good afternoon. Well, thank you, Administrator Nelson. What a fantastic partner. Bill Nelson, NASA, it doesn't get any more fun than that. Still looking for those aliens, Bill.
I am too.
We're here at COP28 as countries are gearing up to begin implementing the Paris Agreement Enhanced Transparency Framework in 2024. I can't think of a better way to demonstrate the United States' support for transparency than announcing this new multi-agency effort to provide high-quality greenhouse gas information and data. The U.S. Greenhouse Gas Center represents President Biden's whole-of-government approach to tackling climate change. 4 agencies, EPA, NASA, the National Institute of Standards and Technology, and the National Oceanic and Atmospheric Administration, are working together to ensure that the United States is the global leader for deploying cutting-edge science to monitor and model greenhouse gases in the atmosphere. NASA has done an exceptional job getting the online portal ready for COP28. Working closely with NASA, our team at EPA has been able to target critical areas for improved greenhouse gas information. For example, EPA and NASA developed a new approach to visualize where methane emissions occur in the United States, which will assist scientists in refining their models and help EPA's continuing efforts to improve methane data. EPA, NASA, and other agencies such as NIST are also integrating data from satellites, aircraft flyovers, and ground-based monitoring to better characterize emissions from landfills. Improved methane data from these efforts will allow us to do a better job designing approaches to reduce emissions. In related work, NOAA developed the approach we use to quantify blue carbon, stored in critical coastal ecosystems such as mangrove forest, so that we can include this information in our greenhouse gas inventory and boost our transparency. For our international partners, I'd like to take this opportunity to describe EPA's commitment to helping other countries improve their greenhouse gas information and for implementing the Paris Agreement. It's well understood that transparency reporting by countries on their commitments is critical to the success of the Paris Agreement. Transparency builds trust and assures countries that if they take on and implement more ambitious mitigation targets, they will also be able to see if other countries are doing the same. Transparency also gives the public the information they need to assess how governments around the world are doing. Through EPA's Transparency Accelerated Capacity Building Program, we're providing technical support to developing countries for the preparation of their first national reports under the Paris Agreement. Our support for these biennial transparency reports includes bilateral assistance as well as training on EPA tools to prepare greenhouse gas inventories, projections, and assessments of progress towards commitments. The UN also plays a crucial role in making the Paris Agreement Transparency Framework a success. The Secretariat has been tasked with developing electronic reporting tools and providing training and assistance to countries so that they can begin submitting their first reports by the end of 2024. I'm also very pleased to announce today that the EPA will be providing $2 million to the Secretariat to ensure that they have the resources they need to complete this important work. Yes. You know, this funding continues EPA's close collaboration with the UNFCCC Secretariat to build the capacity for developing countries. We look forward to an ongoing close collaboration throughout 2024. EPA's technical and scientific expertise continues to set the gold standard around the world. And under President Biden's leadership, we're working in an all-of-government fashion, teaming up with fellow gold standard science agencies like NASA to reduce our emissions, protect our communities, and reaffirm that the United States is the global leader on ambitious climate action. Next, you'll hear from a panel of experts led by one of our key partners in this effort, and new co-chair of the IPCC's Work Group 3, NASA's Chief Scientist and Senior Climate Advisor, Kate Calvin. Thanks, everybody.
So thank you, Administrator Regan and Administrator Nelson. I know both administrators have a very busy schedule, so we're going to transition to our panel, but let's give them a warm round of applause. I'm going to introduce our panel now. So first, we have Karen St. Germain, NASA's Earth Science Division Director. Next, we have Sarah Kapnick, NOAA's Chief Scientist. And last but not least, we have Bram Massakers, a scientist with ESRAN, the Netherlands Institute for Space Research. So thank you all for being here. I do want to take a moment to recognize our partners at NIST, who couldn't be here with us today at COP, but are an important part of the U.S. Greenhouse Gas Center. So with that, I'm going to just get us started with our first question, and we're going to start with a question to Karen. So what type of information will be included in the Greenhouse Gas Center, and how will people be able to access it?
Well, thanks so much for the question. Thanks everybody for being here. It's a real honor to be on the stage with our partners, and we miss those who couldn't be here with us today. This is a true team effort. The center is going to integrate greenhouse gas information from the facility scale all the way to the global scale. So the idea is to create a place where people can get actionable information that's easy to use. We're going to leverage data from federal agencies, international partners, commercial providers, and nonprofits. The center will provide access to curated and evolving foundational greenhouse gas data. And this includes ground observations from NASA, from NIST, and NOAA. It includes data collected from our airborne sensors, and as well as our spaceborne sensors. You heard about one of them from Administrator Nelson, EMIT. We also have two other long-standing greenhouse gas sensors, the Orbiting Carbon Observatories 2 and 3, or affectionately called OCO 2 and 3. The center also includes curated EPA model-driven data and analysis, and curated EPA regulatory and research data sets, as well as research data from NASA, from NIST, and NOAA. And I think just as importantly, it provides tools and code so even advanced users can actually work with the data. It's not just a visualization tool. And I'll just reiterate the data and the information are available at earth.gov/GHG Center.
Sorry. Thanks, Karen. You can give me a round of applause. It's great to hear about all that data, so observations and models, and this is really a multi-agency effort. And so I want to ask the next question to Sarah and sort of take us the next step. So how will this information help people respond to climate change?
And so I'm also representing my sister agency because NIST is also under Commerce. So I'm going to respond for them since they sadly couldn't be here today. They sent me all their notes. So NOAA and NIST are collaborating with other U.S. agencies to integrate all of our complementary methodologies that allow tracking of greenhouse gas emissions, reductions and removals towards the U.S. government net zero goal. This information will help support future global stock takes, but also help guide the U.S. and meet its commitments to the Paris Agreement and the Global Methane Pledge. These collaborative efforts support the new National Greenhouse Gas Strategy and also contribute to the U.S. Greenhouse Gas Center focus areas. From all of this, NOAA has a robust global greenhouse gas reference network program. These are land-based, but also are airborne, different mechanisms for being able to monitor greenhouse gas concentrations in the atmosphere, which allows us to have a 3D picture. So when the satellites are just coming down, it's like a shadow that gives you an information, but then with all of our crafts at different spaces and the ground, we can then actually get a full picture of the entire column, and then how things are moving is then integrated into our inverse models that allow us to bring all that data together about how everything is moving around. So with that, we have also bringing in our partner agency satellite information from JPSS as well as ESA Sentinel-5. And so it's integration of all these different data sets from our top-down capabilities to combine these long-term monitoring capabilities that we have from land with all the modeling to bring in to really understand underlying surface structures of what's happening from land in the ocean, but also natural and anthropogenic sources and sinks. So doing this bottom-up emissions inventory, combination with that top-down approach, allows us to build a comprehensive picture of greenhouse gas emissions, but also the sinks and how they result in the greenhouse gas concentrations that we measure. And those long-term data and models, along with the ecosystem impact assessments that NOAA provides with decision support tools, will be really important for monitoring, verifying the effectiveness of potential carbon dioxide removal approaches as a climate change solution that has been a major topic for us here at COP. And there's large uncertainties with all of this. And so all the work, I think, of us coming together is really important for bringing down those uncertainties. So on the NIST side, I'm supposed to say that a large and increasing share of global emissions are thought to come from cities and urban areas. So NIST has been focused on development and demonstration of urban greenhouse gas measurement capabilities. And from this, NIST and NOAA have partnered on prototyping a system for urban greenhouse gas monitoring to track whether urban-scale climate change solutions are working. And the concept combines top-down and bottom-up methods and aims at operational use while also maintaining the flexibility to go into the center and be able to support the work that's being advanced. And we're collaborating on the GRAPES program, linking air quality measurements to the greenhouse gas measurements and fine particulate scales towards achieving better estimates of emissions. That we also partnered this summer on a field campaign to bring that all together. And NIST and NOAA are working with meteorology community to make anticipated increased demand for these types of high accuracy greenhouse gas concentration standards, 24/7 monitoring for the capabilities from the land surface. And NIST has initiated, as a result of this, an ISO documentary standards activity to develop the technical greenhouse gas measurement standards that are consistent with World Meteorological Organization best practices. So there's a lot of different pieces that we're all bringing together, and I'm very excited about how our science comes together across the agencies to create the best available product.
Thank you, Sarah. And Sarah started to mention international, and let's pull on that thread a bit more. And there's no one better to do that than Bram. So Bram used to do a lot of research in the U.S., but he's now based in the Netherlands. So the U.S. Greenhouse Gas Center is focused on the U.S., but I want to talk a little bit about what's going on globally. So we know greenhouse gas concentrations have increased since pre-industrial era. Can you tell us a little bit more about what's been happening recently and what trends we're seeing?
Thank you. So I think that globally, despite all the efforts, we're still seeing that emissions of both CO2 and methane are increasing, as well as that we're seeing record concentrations despite some regional reductions. I think what's important there is that we're getting a better handle on where these emissions exactly are occurring, because in addition to improvements in surface-based observations, aircraft, which are all still vital, we really have seen a revolution in observing greenhouse gases from space, giving us a much better idea of where exactly emissions are occurring. And I think what the Greenhouse Gas Center is really vital for is bringing that information together and also linking it to the reported emissions. And this is work that we've done together with EPA, which I started during my PhD, where we are putting the emissions from the greenhouse gas inventory, which is a nationally reported number, on a map over the US so that we can actually use that to compare to what we see in the atmosphere, so that we can make sure that these observational constraints are coming together with the reported emissions so that we can make sure those are in agreement, which especially moving forward as we're starting to track reductions will be really important.
Thank you. And now I'm going to talk a little bit, we have a lot of information in the Greenhouse Gas Center, a lot of current capabilities for monitoring greenhouse gases, and you've heard about some of those. I want to talk a little bit about where this might be going, and I'm going to ask this question to all three of you. And so what current and emerging capabilities do you see contributing to greenhouse gas monitoring? And maybe we'll start with Karen.
Well, in our space, of course, we are always looking to advance the technology associated with monitoring, detecting, monitoring, observing, and analyzing greenhouse gas data. So, in addition to the satellite systems that we have up there today, we just closed a competition for a new greenhouse gas observing capability. The proposals are under evaluation now, so probably by next year we'll be able to tell you which proposals have been selected to move in through the first phase. But we're always looking to advance our capabilities to be able to observe from space. And as Sarah mentioned, the methodologies to merge data, to bring together the top down and the bottom up, and in a coherent way so the information is self-consistent and actionable. So there are a lot of analytics approaches that we're developing as well.
Great, thank you. Sarah?
Yeah, so the greenhouse gas portal is pulling together all this data from NOAA and NIST, but it's also a part of the new greenhouse gas strategy. And so I think advancing that, and it lays out what is the future of science in this space. And so we will continue to support what we've developed and committed to now, but I think there will be expansion with the science and the best available science of certain capabilities as, we form this partnership and show how the agencies can work together to create the best available science in this space.
Great. Graham?
Yeah, I think that over the next few years, we're really starting to see a wave of additional satellite data on CO2, but also very specifically on methane, launched by very different types of parties, commercial parties, philanthropy, traditional space agencies, public-private partnerships. So there will be a lot of data coming in, and it's really important to synthesize all of that and bring it together and see what it means.
Great. So we have some new satellites coming, new ways of bringing together data, a greenhouse gas strategy. I now want to talk about how people can access this information. And this is going to take us to something that's really important to me, and that's open science. So the U.S. Greenhouse Gas Center is built on open source science principles and techniques. And so how does this collaboration support open source science and innovation? What tools are going to be available for the community and beyond to use this information and data?
I'm going to jump on that one because it is one of my favorite topics. This is an approach that we're taking really not just across the entirety of NASA Earth science, and not just across the entirety of NASA science, but it's a whole of U.S. government strategy associated with making sure it's not just about making sure our science is open, but it's also about accelerating discovery and the use of discovery by making everything more accessible. Now let me come back specific to the Greenhouse Gas Center. So we've talked a lot about the data, but what about the user experience, right? What happens when you get to the portal, to the website? And it is in its beta version, so you know the information on there now is really built around our first 3 use cases. But the kind of thing that you can expect is first tools to explore, analyze, and download data and information products. So there are things that we call insights. These are sort of stories for someone that's new to this space to get the lay of the land, to understand what we're looking at when we look at the greenhouse gases and introduce topics and data. There's also user support for data exploration via, for example, Jupyter Notebooks. So you can start to explore in a tailored way. And then there's, for the advanced users who are authorized, there's an analysis hub that allows users to perform advanced cloud data analysis with our computational resources. And the another key aspect here is that all the code of the U.S. Greenhouse Gas Center system is fully open source and available for examination and reproducibility. And this gets to, I mentioned the benefit of open science, one of the benefits being accelerating the use and the discovery. But in this domain especially, it's true across the board in our missions, I would say, but in this domain perhaps especially important now is the trust and the transparency. We want people to see exactly what went into the measurements and the observations and the data, especially as we get to higher level integrated information products. That transparency becomes very, very important.
Thank you. Sarah?
Yeah, so we are committed to open source science, and this is a non-starter now in government for our science agencies, the open source data and information being out there. For the greenhouse gas in situ measurements, for our airborne campaigns, for our modeling results, for even the code of the modelings, all of those are available so that the research community can use it, but also, importantly, for NOAA and for NIST, what we're developing in the umbrella of Department of Commerce, we are there to support actually also the buildup of all the products and commerce that will come off of this. And so our data and information on this is already available on the Amazon Web Cloud, so it's already easily accessed. And we're already seeing examples of how people are starting to pull it together to build new products. And I will additionally say that from any of the data purchases that we're also making, because we're also really interested in buying best available data that's out there as well, we have these commitments of how we are using that data and purchasing it will be allowed for research, but it's also put into our architecture for how we're releasing the data as a whole. When we do those recombinations or we're putting new data out, that can include some of our private sector commercial data buys. And as our commitment to be able to provide that information for the rest of commerce to build off of, it is open and freely available. And so that blending of information and all of that we are bringing in, as you said, also the code is available to be able to do that, to reproduce that, to build upon it, to improve upon it. And I think it will be just so important in this space with the speed of innovation that we're going to see that needs to take place will be this commitment to the openness of it. And I think and I know that will help speed innovation in this.
Thank you. Bram?
Yeah, well, I cannot speak for the center as a whole, of course, but I can say something about these emission maps that we've created together with EPA. Those are on the national level based on the greenhouse gas inventory that the U.S. reports to UNFCCC every year, so that's a very transparent process. And then we have published how we went from those national totals to these spread out maps across the U.S. in peer-reviewed literature. The data that comes out of that is all available to everybody. And for this new version that we published a month ago, also made all the codes that we use to go from the national level to a map at a resolution of about 10 by 10 kilometers publicly available, so you can completely trace how we did that spreading across the U.S. of emissions.
Great, thank you. And so it's great to hear, the open source science. It means both we know what's in there and we can trace through it, but it also gives an opportunity for other people to use this and replicate what we've done. So while we've been focused on the U.S. by making that code available, other people can see what we did and possibly do it for themselves as well. So I do want to just take one more question from me, and then I want to give the audience a chance to ask questions. So get your questions ready. The question I want to ask, so collaboration is, really the core of all of this. And so I want to understand, how are the U.S. agencies working together along with international partners to monitor and observe greenhouse gases, and what are the next steps from your perspective? Karen.
Okay, so let me start by saying, when we got the charge to build a greenhouse gas center, and of course, as you can tell by now, it's a virtual center. We're not laying bricks here. But when we got the charge from our bosses, from the administration, they said, hey, look, we don't want to spend 2 years thinking about the requirements for this center. We want to move out. We know there's an urgent need. And so we agreed with our partners that what we would do is work together to identify the first 3, we call them use cases. The first 3 things, 3 capabilities we were going to try to bring to the Greenhouse Gas Center, and then we would evolve from there. And so our focus, and again, this is across the agencies, in this initial phase, has been to focus on these 3 use cases, develop best practices, build our relationships, build our stakeholder community that's going to help us figure out what to do next. So those first 3 use cases, the first one is really closely tied to EPA's data. So it's about bringing gridded greenhouse gas emission estimates from human activities to be more readily usable, explorable, and accessible. So that's the first use case. The second is to bring information into the Greenhouse Gas Center on naturally occurring greenhouse gas sources and sinks, so greenhouse gases in the atmosphere that are derived through natural processes. And of course, when you want to talk about net zero, understanding the natural sources and sinks is very, very important. So bringing all of this into one place for the first time, I think, in the U.S. is really important. So that's the second use case. And the third one is, and this is the one that Administrator Nelson focused on, is large methane emission event identification and quantification. And again, this is from our spaceborne assets, but also from our airborne assets. So when you go to the Greenhouse Gas Center, you'll see those 3 use cases now. Those will continue to improve and evolve. And then we've set up a stakeholder activity. In fact, just last week, I think it was, we had our first in-person meeting in Washington, D.C. To start that process of engaging with stakeholders, which will be where we identify the next use cases.
Great. Sarah.
Okay. I'm going to put my pure NOAA hat on here to answer this question. We are really excited nationally on the collaborations of the center, and then also having the greenhouse gas strategy lays out, and we've put that out publicly so you can see how we've laid out how all of us are going to be working together. But then also in the international arena on this, we're also working on the implementation of the World Meteorological Organization Greenhouse Gas Watch and ensuring that that advances out. And then we also plan on maintaining and strengthening the ties that we have with the agencies as a part of the center, but also bringing in the other agencies that have equities in this space. And where needed, we are taking upon ourselves, too, to work jointly on the common goals and enhancing what we have on our land-based in situ and modeling capabilities in this to make sure that we're supporting these efforts across the national and the international scale. Additionally, we're working towards figuring out how to better include NASA's research satellite data in our NOAA operational setting to make sure that that is being incorporated. We're working with NIST on this urban greenhouse gas emission program, as I mentioned earlier, and also with EPA and all the enhanced inventories to ensure that we have that at the resolutions that are required, that also require a lot of the land-based and airborne-based information and the modeling with the inverse modeling to actually produce the data at the resolutions that could be needed in different types of settings. And then additionally, I wanted to comment that we're working with NASA a lot in the international space, and we're leading on different pieces of critical greenhouse gas infrastructure around the world that need to be developed out, and the science that needs to be developed out there. So all these relationships are going to be so important in these partnerships going forward to make sure that we meet all the common goals that we set out by our strategies and where the science needs to go. And just in conclusion, I'll say that we just need to be tasked with what we're going to build, and then we build and innovate in that science and move towards it, and we're all up to doing this and bringing those partnerships forward.
And Bram, I'm really interested in your perspective as someone based internationally. So what do you see as the opportunities here?
Yeah, so I think especially space research is inherently international because a lot of these satellites look everywhere around the world, so it only makes sense to collaborate. I think a nice illustration of that is one of the anomalous events that is now included under use case 3 and is included in the EPA greenhouse gas inventory. So this was a blowout in the US that occurred a couple of years ago, and it was quantified in research led by JPL, but using data from an Italian satellite, from a Dutch satellite aboard an ESA satellite, the Canadian GHG sat instrument, and then also using supporting data from the US VIRS instrument. So it really shows you that bringing all of these data sources together, we can get a better picture of what's actually happening, also when it comes to these extreme events that are important to quantify.
Well, now we have time for questions from you. So does anyone have questions? Tom has a microphone. Please wait for him to come to you. And if you could please introduce yourself too. Try.
Thank you very much. I'm with the Climate Action Network, and the tools that you're presenting are really very important, and the fact that they're open source is really, helpful. So I have two quick questions. One is, I'm wondering if data is included of the U.S. military, which is the largest institutional consumer of fossil fuels in the world and has 800 military bases, has a huge carbon footprint. And I'm also wondering if you have any data about the worst methane leak ever, the sabotage of the Nord Stream pipelines in the Baltic Sea. Thanks.
Who would like to start with that?
I'm not sure I'm going to give you an answer that you're going to find satisfying, because the truth is I don't know the specifics of the locations and the dates and so forth that you're talking about. What I will say is that that EMIT is it's not quite. Let's see. The orbiting carbon observatories are global. They do see the higher latitudes. The EMIT sensor goes up to the high mid-latitudes. So when we observe, and this is one of, I think, the key points of complementarity between the ground-based observations, the source-based observations, and the space-based observations. The space-based observations can see everywhere. So it is possible to see all of these kinds of events and locations from our satellite-based information, even where we are in data-sparse regions when it comes to detection on the surface, surface-based data. I don't know. Do you have anything to add to that?
Yeah, I'll add that it shows the importance of both types of measurements, because if the satellite moves out of the space and then you have a very pointed event that releases something, you might not capture it. And so that's why there's this complementarity of pulling together the land-based and the airborne information along with the satellite data to be able to create that remap over time to try and understand what is happening with when you put it into the inverse modeling to produce these types of maps where you have it continuously, even if the satellite's not continuous or the surface-based measurements aren't continuous. You can do that with the modeling to then produce this. that's why it's also so important why this work that NIST has been advancing on understanding the sources of greenhouse gases in urban centers, which are increasing in the locations, is if you create these long-term monitoring locations 24/7, you then know where things are coming from. And so in these places where we have known sources, be them natural or anthropogenic, setting up those types of monitoring systems allow you to know much more about what the sources are. And so they're depending on what you're trying to measure and what you're then potentially trying to manage or you're trying to report upon, creating these architecture of all these different types of levels of the observations and the satellites and then the modeling allows you to get that picture at the problem that you want to know.
Thank you both. And I realized when Sarah was speaking that I never told you all what you've been looking at for the last 45 minutes. So I can do that quickly and then we'll take our next question. So these are two visualizations. The one on the left is carbon dioxide. The one on the right is methane. And they are combining different types of information. So we have both satellite-based observations. Like on the left, it's from the OCO satellite, which observes carbon dioxide concentrations globally. And they're processed through models. So we can see the sources of those emissions. And the animation's playing that out over a year. So you're just looking through 1 year, month by month. But with that, next question. All right, we have 3 over here. Tom?
Hello, thank you all for being here. I'm an undergraduate student at Vanderbilt University. So I'm curious, as you talk about building out future use cases, if you see capacity for modeling future emission scenarios, and sort of what assumptions, how you manage assumptions as you do so.
Should I take that one? So before I came to NASA, my research was on future emission scenarios. And I will say we used all of the data they talked about as ways of input into the model. And the better data you have, the better your model is. And so when you project those emissions in the future, you can better understand the effects that they'll have on warming.
Yeah, can I add to it? Yeah. And then on the natural system side too, having the Earth system models that we both have developed at NASA and NOAA are then also really critical to have those Earth system models as we understand what's happening to the natural environment, which is changing in its greenhouse gas properties, particularly in wetlands, in the Arctic locations, in the boreal forest with wildfire, and then bringing that all together about what the risks are, particularly as there's interest in what's happening in potential market-based solutions. Having all that information and forward-looking into it with the risks associated will be critical for how things get structured or used.
Next question on the end here. Oh, back here.
I'll stand. Hi, my name is Emily. I'm also an undergraduate student at Duke University, and I'm not sure this is within the scope of this project since it is the U.S. Greenhouse Gas Center, but I was kind of interested in the talk of international partnerships as well as the integration of like satellite and land-based observations. So obviously in the United States, we have a lot more observing places based on the ground, and so I was kind of wondering what the opportunities, or if you were looking into partnerships with other nations, particularly in the global south, to potentially scale up their observation capabilities or anything like that. Thank you so much.
This might be one that all 3 of you could take. So maybe, Sarah, do you want to start? Or?
Sure. Yeah, through the WMO project on being able to monitoring, there are gaps in the global south in the land-based but also the airborne-based information, and that those gaps lead to less information to be able to do the modeling within the column or even abroad. And so there is a call, and I made this call in plenary the other day, that we need to form more partnerships in the global south with those monitoring capabilities. Something I also didn't mention today is that those air samples that we take are actually really important to actually capture the air itself, because the carbon dating on that allows us to know the sources of those greenhouse gases, if they're fossil fuel and very old, or if they're newer sources from biology that are coming out right now. And so having those ground-based canisters around the world and that network and building that out further allows us to have a better handle on what's happening naturally versus anthropogenically in a changing climate, in a changing ecosystem environment, responding to climate change, so we can close some of those uncertainties of what's happening and build it out further.
Karen or Bram?
So, I mean, maybe something I can say about international aspect of satellite observations is, again, that a lot of these satellites look everywhere around the world. I think a great example of how that data can be used is the International Methane Emissions Observatory that's operating under the flag of the UN, and it's taking in satellite data, including some of the ones we discussed here, and then making sure the information about large leaks that are detected gets to the right people. So the relevant governments, the relevant companies, so that when they don't know about these leaks, this information can actually help to solve these leaks.
And I'll just bring it back to the super tactical with the Greenhouse Gas Center. Well, we've already mentioned satellite data is global, and we've also mentioned that we're developing tools, methodologies, standards, and so forth as a part of the process of building out the current instantiation of the Greenhouse Gas Center. There's nothing about those that are inherently
So when we infer greenhouse gas fluxes on the and I'm wondering what you think about this and whether you could have cloud-based computing available to stakeholders in this way.
Yeah, I think. Did you want to go? I think it's a great question, and yeah, I mean, part of what we're trying to do here is, I'll use the phrase loosely, but democratize the access and the insight and the information and the ability to do the science. But I will not tell you we've got it all worked out. But that is one of the reasons why we have the user support tools and the everything from the Jupyter notebooks, which I understand is not what you're referring to. You're referring to the heavier computational work. But yeah, that is the point. And this all is cloud-based. So and that was done with intention to make it scalable in these ways.
All right, I think I saw two more questions on this side, and then unfortunately we'll have to wrap.
Thank you very much. Orlando Cabrera from the North American Commission for Environmental Cooperation. Can you hear me?
Hold it a little closer, yeah.
Oh, okay. I'm from the Commission for Environmental Cooperation from North America. Thank you for the presentation. Great tool. And you mentioned already, or you touched upon, the reconciling the satellite observations with ground and emissions inventories. And the question is, based on the preliminary work, what's the gap in terms of coverage, in terms of emissions? How much do they differ in terms of what is being measured via satellite versus what is being estimated or reported, and where the gaps are? And then that will tell us where we should fill in these gaps.
Okay, so I think he's asking about gaps between what's observed and the activity-based and how we resolve those. Does anyone want to?
Do you want to start? Yeah. I lip read a little bit when I can't hear, and you have a beard, and that was a little hard for me to hear perfectly. So I will answer the question that I think you asked, which is we need the ground-based information to be able to ground truth the satellites too for the CalVal, but then for the valuation to make sure that you have the right algorithms for the satellite. But then additionally, to be able to fill in that information between different spaces and different times when the satellite's not there, you need the ground-based information to also fill it out to be able to do this type of modeling. And so it's not you can have one or the other because we would never, the cost of a fully ground-based network continuously would not be possible. And so it's a matter of optimizing and figuring out how to optimize where those observations are. And I think the exciting part about moving the cloud and the advancements in satellite and the advancements in inverse modeling is we can make more and more decisions about where are the critical places to put more of those ground-based observations to be able to augment and improve our skill, and where are the areas that and the field campaigns are used to understand where are the areas that we have the biggest uncertainty and how do we evaluate that uncertainty and then how do we resolve it and fix it. And so it's not a clear either or, it's a co-development of both to be able to, what is your design of your observational system on the land and your aircraft to be able to get to the level of precision that you want. So it's a matter of also the question that you ask.
I can add to that a little bit, which is from the space-based observations, we always have to choose between the spatial resolution, the accuracy, and the temporal refresh. I'm simplifying a little bit, but that's generally the trade space. We have, particularly because carbon dioxide is so difficult to measure from space, because it's a very small, any change is a very small signal riding on top of a very big signal. That's the hardest thing for us to be able to detect with remote sensing. So we have always, we have favored accuracy and spatial resolution over temporal refresh so far. So I think one of the gaps really is temporal refresh, and I think that is important for actually both anthropogenic sources and really getting to understand the natural sources and sinks. So I would say that, and also that one of the other things, synergies between space and surface-based is the space-based observations can tell you where to put the surface-based observations, and so I don't think we've quite fully exploited that synergy yet either.
Ooh, can I add for NIST? And if NIST was here, they would also say, the standards of the precision is something with what they're launching and the work that they're doing is also super important for us to know what is the skill that we have in these places. And that's why some of the advancements in technology that they're looking at in the urban environment, use of lasers and use of other technologies to be able to detect, becomes so important, because the work that they're doing can create those swaths in small areas to really get to how much do we really know at a higher precision level than we get from our other capabilities, which then, as we decide what are the standards for when we're building this map, helps us understand what the limitations of our capabilities can be with the systems that we have and what do we need to build for going forward.
All right, and now for our last question.
Hi, it's a great and fascinating visualization here. My name is Jay Coe from Lightsmith. We're actually a private investment firm focused on the adaptation and resilience to climate change. It's great to see such expertise here. And so my question is a little bit related to the one about interaction beyond the scientific community with the rest of the stakeholder community. In this case, commercialization and investors, right? So this is amazing information, basic science being advanced. You're seeing a large-scale partnership with the private sector in privatization of parts of space, including Earth observation, numerous different types of sensors being put into different constellations out there. And can you just comment on how the thinking is evolving within the United States government, at NOAA, at NASA, parts which are inside the Commerce Department, on creating that interface with commercial and investor stakeholders? You spoke about resolution and refresh rates. How is input being taken into from the point of view of what investors need, what corporations need, individuals in the private sector need? Is there a place for the creation of something like a commercialization interface like ARPA-E was in some ways, to take technologies and bring them into the private sector, to bring them and expose them to investors and to commercial users? Because it seems like it's amazing impressive scientific information, and then I have no idea how to turn that into something I can use in trying to make active decisions about investments. Thank you.
Okay, I think Sarah's going to give us a quick answer.
To be super fast, that is why we have the setup of the new oh gosh, I'm blanking. We have actually a new center for commercialization in space. There's the Space Office now within Commerce. Department of Space Commerce is what it is formally called. We also have programs around what is the future of commercialization of this type of technology and science, of which we have been putting out strategies and been working with USPTO also on fast tracking for certain types of these technologies to get a patent within 12 months. Seeing this as a critical area of climate mitigation that needs to be focused on. And then additionally, with all the partnerships, there's the discussion about how do we do our data buys to be able to incorporate into this. And that was part of the reason behind the greenhouse gas strategy being released by the White House last week, is we know what the scientific pathway is, and we are publishing what we think the best in science and what that pathway is. And there's space for development within those things. And so with the strategies around this future of this science is laying out where we think we need to go. So we are clearly explaining that, and then that creates opportunities for people to go into those spaces and be able to advance that science and technology.
Karen's going to give us 20 seconds, and I'm going to close it out.
Okay, so one pathway is NASA is very serious about pushing our technology out to the private sector. So one example of that is the Carbon Mapper Inc. is partnering with JPL, NASA, to develop their capabilities. But I think the more important answer is, I mentioned the stakeholder engagement with the Greenhouse Gas Center. This is not intended to only be federal agency stakeholders, private sector. To get to exactly the question you're asking, that's the place to bring those needs to the table so we know where to go next.
All right, well, let's thank our panelists. And if you're interested in visiting the new U.S. Greenhouse Gas Center, it's at earth.gov/GHG Center. So thank you all.
A round of applause for our wonderful panel.